Understanding gradient of tangent to the curve. So in this part, gradient means dy dx. So every time when you talk about dy dx, it is a gradient. The straight line y equal to 1 over p px plus 5 is parallel to the tangent of the curve here. So you have a curve equation which is this at point q. Point q is at x-intercept. Find the value p. So this means that I have a straight line. This is a straight line with the equation of this. And this equation of straight line is parallel to the tangent of the curve. So to the tangent of this curve. So let's say this is a curve and this is tangent. So tangent means touch the curve at one point. So this touch the curve at one point. This line is tangent of the curve. So this is what they say. So they say that the straight line y equal to 1 over 3 px, this line is parallel as this line because this is tangent to the curve over here. So this curve equation is this at point Q. So this is point Q. And point Q is x-intercept, means y equal to 0. So you are finding value of p. So to find value of p, this p is a gradient. So this gradient over here is m equal to 1 over 3p because I know that y equal to 1 over 3px plus 5. Gradient is y equal to mx plus c. So your m is equal to 1 over 3p. And this is parallel. This is parallel. This means that this gradient will be also 1 over 3p. So to find gradient, what I need to do is to dy dx the equation. I have here y equal to x minus 5 over 2x minus 1. So I make my u equal to x minus 5 and v equal to 2x minus 1. So what I do is to use quotient rule to differentiate this. So my u prime over here will be 1 and my v prime over here will be giving me 2. So differentiate this is u prime v minus v prime u over v squared. So my u prime is 1, my v is 2x minus 1, minus v prime is 2, u is x minus 5. So over v squared. So what is v squared? v is 2x minus 1 squared. In this case, if I make this as a wall, can I compare? Is there any similar? No. So what I do is to expand the equation and I will have this answer over 2x minus 1 squared. So 2x minus 2x, negative 1 plus 10 will give you 9 over 2x minus 1 squared. And this is dy dx, it's a gradient. So means that to find this gradient, I need to substitute the x value. But in this question, they say that it passed through the point Q and you have x 0. You have y value, but you do not have x value. So what you do now is to find the x value. So y equal to 0. So y equal to x minus 5 over 2x minus 1. Make this as 0, x minus 5 over 2x minus 1. Bring this up, you will have 0 equal to x minus 5, so x will equal to 5. So substitute your 5 in this dy dx, you will have dy dx equal 9 over 2 times 5 minus 1 squared. So 9 over 10 minus 1, you get 9 squared here. So cut this both off, you will have 1 over 9 as your gradient. So this gradient 1 over 9 is in this part. So this part will be 1 over 9 equal 1 over 3p. So to find p, bring this 3 to that side, you will get 3 over 9, which is 1 over 3. So your answer is 1 over 3 for p. Understanding gradient of tangent to the curve, the same part we are trying to do given the equation of a curve, which is y equal to this equation is this curve. Find the equation of the tangent to the curve. Let's say this tangent to the curve is here at this one point, where this point is p1 to the 5. So first, every time when you try to find equation, it is y equal to mx plus c, and you need to find the gradient. So what you have here is y equal to 5, 2x minus 1, negative 2, power of negative 2. So to find gradient, I need to do dy dx, as dy dx is the gradient. So negative 10, 2x minus 1, negative 3 with 2, and negative 20 over 2x minus 1 to the power of 3. So every time when you try to find a gradient, you need to know how to differentiate an equation before you start to do all these questions. And substitute the x value to find the gradient. So I will have 2 times 1 minus 1 cube. 2 minus 1 will give you 1, so 1 cube will give you 1. So negative 20 divided 1 will then give you a negative 20. So this is your gradient. So you have y equal to negative 20x plus c. Now I need to find c, but I have to coordinate 1, 5. Now I know that this gradient is m equal to negative 20, and I also know that this equation is almost done, which I have y equal to negative 20x plus c. So to find this c, substitute the coordinate of the line, which is p15. So put it in. And at the end of the result, I will have the C answer, which is equal to 25. So y equal to negative 20x plus 25. So this is the final answer.